Okay, Bismillah ar-Rahman ar-Rahim, wa salatu salam ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, I'm going to make you an introduction to Python. Okay, so this makes part of the training program I did about Python for data science, and it's going to be the part 1. And I will introduce the basic notion of the Python programming language. Of course, in the other courses I talk about data structures, and then another course about data visualization. So this course is going to be about the syntax of Python. So any one of you knows Python before? Or this is the first time? Okay, only one. Okay, so I think most of you already know Java and maybe some other programming languages. And it's not good. It's good not to learn Python as a first programming language, because it is very easy. So if you learn Python, you're not going to use anything else after that. So that's why it's very, very powerful programming language. It has a lot of library, a lot of tools. It's now the programming language #1 in data science, in deep learning, in almost any area for now. It can be used for web development, it can be used for data analytics, it can be used for network programming, for simulations, many things. It can also replace MATLAB. So it has a lot of usages. And I think this is due to two important aspects. First of all is the easiness of the language. It's pretty much straightforward and easy. And also the number of libraries, okay, that are developed for different applications and different use cases. So in this first introductory crash course, I'm going to give the foundations. So in part 1, I will talk about the basic syntax, the data types, the operators, how to make decision making, the loops and strings. It's like the CS 101 that you did with Java. Okay, and of course later on, when we find time, we can do data structures and also Lambda Expressions. Yeah, I'm going to talk also about data structures in this particular crash course, and also functions, Lambda Expressions, map, and filters. Of course, I prepared this tutorial based on different documentation, so I assume that it's comprehensive, at least for the basics. And when you want to work with Python, you have different ways. The easiest way is to use Google Colab, because it already have the Python pre-installed with all the libraries that you need, and it has a lot of library already pre-installed. Or you can use your own Python installation. I'm not going to talk too much about Python framework and packages and so on. But the easiest way also, if you want to work locally, is to use Anaconda. I think most of you, they have used Anaconda because you have worked with deep learning. So we can do the same thing using Anaconda, and you install an interface like this, and you can run a Jupyter notebook. So Google Colab also provides you an online Jupyter notebook, where you can write Python commands, you can write also system commands, and you can write some text in HTML. And the good thing is that also you can download these as a Python code. Okay, yeah, you can make download.py. So at the end is going to be just a file as a Python code. All the text will be as a command, and the Python code will be written down there. Okay, and then you can execute using Python and then the name of the file. Okay. So the other way, as I mentioned, you can use Anaconda. You just need to install the software and then launch the Jupyter notebook. Let me start it here. Okay, and then you browse to your directory. For example, in my case, I don't remember exactly where I did it. Probably it's here, where RIOTU Lab should be somewhere, training. Python for data science, day 1. and then I will open this one. Okay, so basically it's the same thing. You can work locally. So if you want to execute a cell, you press Shift, Enter, it will execute the code. Okay, and then you can see the output. And Python is an interpreted language. You know the difference between compiled language and interpreted language? Yeah, so compiled language, usually you write your code, then you compile. When you compile, you are going to generate binary code. And then binary code is going to execute it. And if you have compilation error, it's going to detect in advance, like you do with Java or with C. Okay, usually you generate some kind of binary file, and this binary file is going to be executed on the operating system. This is compiled programming language. Interpreted programming languages, they work differently. They don't compile, they will execute the instructions one by one. Like, for example, JavaScript or Python or BASIC. There are several, and of course everyone has its different usages. So that's why even if you make an error, you can still execute the code until the error comes, because it is going to execute line by line. Every line is going to be interpreted. Okay? It will not compile, it will not generate any binary file. So you can have some errors in your code, and these errors, okay, so it's going to execute. For example, if you have the error here, all this code is going to execute, and then whenever you have the error, it's going to stop and print you a message. So in this case, you have to debug. Just to know about the difference between both. So let's get started with the foundation. In this notebook, we provide an introduction to Python 3. Of course, Python went through different versions. The most popular ones is 2.7, and now most of the work have switched to Python 3. They are compatible most of the time, but not every time. So some syntax are proper for Python 3 and do not work on Python 2.7, and probably vice versa as well. So let's start with the basic syntax. So in every programming language, we start by hello world example. Okay, so in Python, you don't need to create a main function, you don't need to create any method, you just write instructions. Now, for example, if I go on a terminal, okay, we can open also, it's another way how to execute Python code, is to write Python. We can write python.version to check which version we are running. So I'm running the version 3.7, and then I will write Python, and then here I have the prompt for writing Python commands. Okay, so for example, I'm going to write import NumPy. Okay, now it's imported. Okay, I can make print hello world. So it will print it. Okay, so you can make some terminal commands, but it's easier to work on Jupyter Notebook. So here, if you want to make a comment on Python, you need to use this sign, the sharp sign, to write comments. And then print is going to print the text, and you can put it between parentheses. I think also, no, we need to use parentheses here to print. In previous versions, you can print without parentheses. Okay, so here we start by printing a hello world message using the method print. In Python 3, it is necessary to put the text into parentheses, whereas in Python 2, it was optional. So this is one of the differences between Python 1 and Python 2. Now, something also, and they consider this is the most difficult part in Python for some people who have already learned other programming languages, is that you don't use semicolon. Because usually we are, like in our unintention, whenever we finish a line, we're going to write semicolon. In most of the programming languages like C, C++, Java, Pascal, and so on. But in Python, you don't need to do that. So in order to differentiate between blocks, we need to use indentation. And it has a very nice property, is that the Python code should be well formatted. You cannot write like in any line with any space and so on. So space and tabs, they really count for everything. So and an indentation space, it defines a block. Like you open a parenthesis, for example, for an if statement or for a for loop or for whatever. So indentation is very important in Python. It determines blocks as no parentheses are used. And this is an example of an if statement. So here we use an if statement. So we make an assignment, I equal to 0, if I equal to 0. And then at the end of an if statement, we use double colon. Okay, it's like you open a parenthesis. And then you have to make indentation. Look now, for example, if I don't make indentation, if I do like this, first of all, it's going to show that there is an error. And if it compiles, unexpected indent. So that's why you have to put it, even this, the indent doesn't match. So you have to put it exactly the same number of spaces. So if I add the space here, I add the space here, it also works. But it didn't work for, okay, so it works also. Change the value of I to another different from 0 and observe the resulting output. Of course here, because we have used an if statement. So if I don't put the if statement here, if I put 1, it will print only n equal to 1. Okay, so what you learn from this example here, for the if statement, you have to use a colon. Okay, and the equality check is like in Java, you use equal, and then you have to make indentation to define spaces. Okay, so now about data types. Here in Python, it is possible to create variables and to perform operations on them. And Python is dynamically typed language, and this is mostly for the interpreted languages. Now with compiled, you have to specify the type, int x equal something, or string or whatever. Now in Python, no. You don't explicitly define a type, but it is implicitly defined depending on which value is assigned to the variable. For example, here x equal to 3. So we know that x is an int. The interpreter is going to know that x is an int. Here it will know that y is a double. And here it will make the sum of both. So it will consider that z also is a double. Okay, and it is possible to determine the type. So now you want to know the type of a variable. We can use the method type. Look now, if you make type of x, it will return class int. So this is the type of x. And here it's float. Okay. And for z, it's also float. Look, we have made the sum of an int plus a float. So it automatically recognizes this as a float because float is more general. Huh? Yes, it's like double. Even float in Java, it's defined. Like in double is usually bigger. Okay, it can define bigger numbers. So let's create more variables with different data types. Here we can create string variable. For example, name equal Muhammad. We can print the name, and here we can print the type of the name. So it's going to show str. We can define Boolean variables, flag equal true, and here is going to return Boolean variable. We can also define hexadecimal variables. W equal 0x, you know this symbol of 0x, it's for hexadecimal. Okay, FA2, yes. So this means we are going to write an hexadecimal number. Okay? Look now, we can create an hexadecimal number either using 0x, and then we define an hexadecimal number from 0 to F, 0 1 until 9, then A, B, C, D, E, F. Okay? For example, here FA2. Or we can use the method X. So X, and we give a decimal number. It's going to convert it. Look now, if I print V, so this number is going to be converted to 0x 223. Mm-hmm. What? Yeah, this is the notation. This is a non-notation for hexadecimal. I mean, 0x is always 223 is the hexadecimal number that corresponds to this one. Huh?
When you hex something, it's stored as a string.
Sorry?
The hex 547, is it stored as a string?
No, it's stored as the type is a string here, yes. It made it as a string. W يعتبر int. نعم. يعني الانت هو عام بالنسبة لي سواء decimal هو ما يقولكش هذا hexadecimal, it's an integer. Okay. Yes.
بس هو الكتب اللي هنا حول الاكسل الرقم مضبوط.
نعم.
ليش ما حفظوا كسر؟
نعم.
ليش ما حفظوا كسر؟
ليش ما حفظوا؟
as a string.
كسترينج.
لأن الهكس 547 is a number.
لا، لأنه هنا هذه الهكس it's a method that will return a string. Okay. Yes. So now, for example, if you want to do this one, we can print x of w. خليها هي نفسها. It will be the same. Okay. But if you print w as an int, it will just put you the decimal. Look. Look, now this is a converter. I will write a number and I will convert to hexa. Okay, so this number corresponds to this one. Now, the convention of the notation and how to write it is that we use 0x and then some number. So 0x doesn't mean anything, just it refers that it is an hexadecimal representation. Okay, like in what counts, what comes after. So look now, if I put this number here, FA2, and here I have FA2. Okay, the conversion between decimal and hexadecimal, in principle you did it in the first programming, in digital logic or something like this, yes. And of course, why it is str and so on, this was how the Python was designed. Okay, so, and it is possible to remove a variable. Now, when you create a variable, it will allocate some memory. Okay, so if you finish using the variable, you can delete it from the memory. And in this case, you can use delete. Look, if I make delete x, then print x, it will make an error because its x is not defined. Okay. Now, if I remove delete x, okay, because delete x here, I cannot print it anymore. In Python also you can do multiple assignments. it is also possible to assign the same value to multiple variables at the same time. For example, x equal to y equal to z equal to 3.2. That is possible. And then if you print the values, you will find them, all of them equal to this. Or assign different values in the same line. This is more powerful. Look, name, age is a student, equal Ali 22, true. It's possible. So I have different ways. No, this is the variable name, and these are the values assigned to the variable. Voila? Okay, so instead of making name equal Ali, age equal 22, student equal to true, you just put them all in a row. It's up to you. I mean, if you choose this one or choose any other, I'm showing you the different capabilities of the language. Okay, you can also define a method. Look, define my function, and the function will return x, y, and z. Function, you just put x equal to 9, and then even I don't need these ones. Okay, so return x, y, z, and then what I want to do, I want to initialize two variables, a and c, by calling the function. So the function is going to return how many variables? 3. So the first variable is going to be assigned to a, and the last variable is going to be assigned to c, and here it's just, for example, I don't need this value, so I just keep it. I can put b here, okay, but I may just put it like this because I don't need the value. Look, now b is not defined. Now if you want to define here a variable b is going to take the second value and will be shown here. Okay, but for example, if you don't need this value, okay, I will not print b, and I will just take a and c. Okay, this kind of assignment is very, very much used in Python programming language. It's useful to know because you will find it in many codes. Okay, yes. This is the language capabilities, you know. The guy who designed the language, he did it like this. Now, if you do this in Java, it's not going to work, right? Okay, because every language, you can design your own language. I can make another language, you know, it takes some other forms. This is what we call, I don't know if you are in computer science, there was a course that is called programming languages. It tells you how to design a programming language, how to create a new programming language, which we call the grammar. You can define your own grammar. Like, for example, in C, the grammar, it uses parentheses to define blocks. Here it uses indentation to define blocks. In other programming language, it uses begin and end, like in Pascal. So every programming language is defined in the flavor of the designer, how he wants to make it. Yes. Okay, if you make A and C now, so you are going to take, it will make an error. Okay, why? Because you have to unpack 3 values, but you are assigning only 2 values. So this A or this C is going to be the second or the third. We don't know. So here, a syntax error. Okay, of course there is a syntax checker that will check whether there is something inconsistent or not. Now your function outputs 3 values and you are assigning only 2 values. What about the third one? Now if you want to skip a particular one, you need to put this hyphen. Wadah? Okay. Python also defines natively complex numbers. You know complex numbers? I square equal to -1. Okay? So you can define A equal to plus 5g. So here g is actually the imaginary unit. Okay? It's known as the imaginary unit. And then you can make add. So it will add the real part with the imaginary part. Okay? That's why add equals 7 plus 17, 2 plus 5, 5 plus 12. You can make multiply, it will also make multiplication, and you can make divide, and it will do division. And this is very powerful. You know, this, for example, is not defined in Java. Okay, and this is why also Python, it's up to use MATLAB, because MATLAB, some toolboxes offer this kind of functionalities. Okay, and Python is free, open source. Okay, so you don't need to buy license of expensive programs. Of course, MATLAB has its own very specific features that you probably cannot find, like specific toolboxes or signal processing, or for robotics, image processing, and so on. But also Python now start to have much more of these libraries. You can also convert between types. Now imagine that you have defined a float and you want to convert to an int, or vice versa, and so on. So you can do that. Let's define x, 2.354, and now you want to convert x into a float, into an int. Convert to a complex to an int. Okay. So the type of x is float, the type of n is int. Okay, so we can use casting, like you do casting. Okay, I can convert n to a float back, and here it's going to make 2.0. So we lost the precision, because when you convert to int, you lost the precision. And then when you convert back to float, it's going to put 0 by default. You can convert it to a complex number as well. Just cast it to a complex, and here it's going to make 2 plus 0g, okay, and the type is complex. And you can convert to a string, strx. Okay, so you can see the syntax is very simple, straightforward, just need to know. But you don't have to memorize. You know, I've been programming with Python, but I forget very often these kind of things. Whenever you look on Google, you will find right away. But it's good to know that the different capabilities, at least for you, when you read some other codes, you are able to understand what's going on. But Python is very flexible, and whenever you need some methods, you can Google it and find any appropriate things. So the math functions, we define also math functions like other programming languages: the cell, the floor, the log, the exponential, the square root, the power. Okay, so you can see here I define 3 values, x, y, and n. So the absolute value of x is ABS, is going to return the absolute value, and the ceiling return -2, the floor. So I put you here a negative number and a positive number to check. For example, the ceiling of -2.5 is -2, and the ceiling is 3.54 is 4. It always go up. Okay, here also it goes down. And then you can have different methods. Here it's just a subset of methods: log 10. Okay, so this is the log at the base of e. This is at the base of 10, and exponential, square root, and power. So for the basic operators, of course, like any programming language, you can do additions, subtractions, multiplications, and divisions. You can also make the modulus operation, which is the remainder of the division. And you can also do here, what is this one? It's power. Yeah. A at the power of b. So it's 2 at the power of 3 is going to be 8. And to print also you have different ways. Okay, imagine that you have 3 variables, name, age, and GPA, and you want to print them. The student is Muhammad, is 20 years old. So you can write in this way. And here, look, I have used double quote. And then I used like a colon, to separate between the strings. This is like we do with Java, with printf. With printf. نعم. Plus sign. صح. And here you can use curly brackets. Look, you can write it all together. And curly brackets A, B, J. Then you use dot format at the end of the string, where A equal to name, G equal to GPA, and B equal to H. It's another way. Okay? Sorry? I say printf, it's here. Last one is like printf. Use %s, %d, point to f. And here you specify name, age, GPA. You have to put % between both. Okay? And here you can use just curly brackets empty. And here you can use name, age, and GPA. It will take in the order. So many ways. واضح؟ Yeah.
If I switch between name and GPA, it will give an error, or it will print the GPA in the name list.
Which one?
This one, the line.
Yeah, if you switch, it will switch. Not an error, because you don't specify any type here. Okay. Because I did not run this. The student 22, because age is the beginning. But the error will be here, maybe. Okay, now if you put age and name, so there is an error. Because % D here, it was made for having, it accepted %s for age, but not the opposite. Okay, so if I put %s here, it will work for everyone. Like, yes, %d here, it will be an issue for name, because name is not an int. So this one you have to be careful at the order. This one, it can be in any order, but of course it will be inconsistent if you switch the order. Okay. And here, for example, if you put B equal and A equal here, it will switch. Now, you want to do system that, like scanner, you want to read from the keyboard. Okay? You want to make a prompt. And here you have different ways. So we use the method input. Okay? Yes, so here look, what's your name? It will make a prompt. So I will write Anis, for example. Welcome to this Python course, Anis. What is your age? Okay, 43. Okay, so it makes the printing here. So you use the method input, and then you put between parentheses your question. Then it will assign the value that you put here, and then you can print it. And of course, look here, when I read the age, it's going to be considered as a string. So you need to convert it to an int using casting. Okay, now for example, if I don't do that, type of A is string, age, and the type of A is integer. So everything is going to read is going to be string. And that is up to you to cast it to the correct type. ايش؟ ريسيت يعني ايش؟ لا خلاص اذا كنت سويت لها ران في فوق هنا في هنا stop. إذا كان something looping you can stop. Here. So the conditional statement, if and else, we did that. Okay. So here it will ask enter the GPA, you will enter a value, and then you can make if statement. If the GPA is smaller than 2.5, print fail. So else if, it's written like this, else if. So this is another statement, else if. The GPA is smaller than 3.5, not bad, else, good. So we can try that. Okay. So here you have to know that else if is to make another condition, and else is the last condition for if anything else is not correct. You can make loops also. In Python we can use loops and while loops. We can use a loop for specifying the element to iterate over. So here we define a sequence. We are going to talk about sequence. This is what we call a list in Python. And we can define a list like a simple array, static array. And then here we can make a for loop for every I in the sequence, like the for each statement in Java. Okay, it will write I equal, I have used the dot format expression, I plus 2. I just, for example, add 2 to the operation. It is also possible to define using the range. Range 10. Okay. So it's a range between 0 and 10. It gives you a range 0, 1, 2, 3, 4, 5, 6, 7, 9, 10. So if you want to go through 5 iterations, you can make for I in the range 5, print I. Okay, so here we have 5 indices. And this is like you do for int I equal to 0, I smaller than 5, I plus plus. So just do it using the range, looping using the range. If the number of iterations is not known, احنا في الجافا استعملنا iterator صح ولا لا؟ Okay, so here we can use the while loop. Like in Java also we can use the while loop. So n equal to 1000. So flag equal to true. So in this case, print n. If n is not divisible by 13, is divisible by 13, then the flag is false, and you exit the loop. Of course, if you change here 1000, you will have different number of values. Okay, so in this second notebook, I'm going to talk about data structure, and this is even more important. And by the way, the very big strength of Python is data structure. And the most powerful data structure that is currently now used in deep learning is the NumPy array. I'm not going to cover today. We'll cover in future sessions. But also the other data structures defined in Python are also very powerful and diverse. We have lists. We have what you call dictionary. Okay, dictionary is something similar to maps in Java, and tuples and sets. So we will see the difference between these different data structures. So the data structures of Python represent one of the most powerful features of this programming language. They provide flexible means to store, access, and manipulate data in a simple fashion. A data structure in Python is a sequence of elements where data are stored, accessed, and manipulated. But of course, they are stored and accessed and manipulated in different ways. We will go through the main data structures defined in this Python notebook. So the first data structure is what we call the list. And the list is the simplest form of data structure in Python, which consists in a sequence of elements stored all together. Let us define the following list, which stores sequence of elements. Now, list is like arrays. Now, arrays in Java, for example, they are typed. You need to define a type, an array of strings, an array of objects, an array of integer. Now, here we call it list, and you know that array list and list in Java are pretty much similar. Okay, so here the list defines something like arrays in Java. And you can store different type of elements because the types are dynamic. Okay, the types are dynamic. So here I define my list, and the first element is 1, second element is Muhammad, third element 3.2. Look, I put 3 values of different types. Okay, and this is if I want to print the list itself.
Is the size dynamic?
The size, you can add elements. You can create other lists from the list, but not in this one. So an element also can be accessed by its index. For example, the ID is the index 0. The name is index 1. So here it's like the notation of an array using the index. GPA and is a student are the index 2 and index 3. So the indices starts from 0. And then you can print all of them, of course. The ID is equal to 1, name equal to Muhammad, GPA 3.2, and is student equal to 2. It is possible to access a sublist range between 2 indices. For example, I want to access between element 1 and 3 only. So here we specify the start index, which is included, and the end index, which is excluded. So when I say from 1 to 3, it's going to take 1 and 2 all together. Look now, this is the sublist. It will select the index 1, that is the name, and the GPA. Okay, using this notation. This notation is very much used in data structures because sometimes you need only some subsets, slices, what we call slicing, exactly. You can update the value of the list. For example, I want to change the name to Salah. It's possible. Okay, now imagine that I want to change give me the ID is an int. If I want to change this one to a string, so you can do it. The type is, it will change. Okay, even if I do for the GPA, for example, the type will change. Okay, so the type is dynamic. The type is dynamic. Okay. And of course, we can loop over a list for every x in the list, like we did for the sequence. Okay, you can print all the different values. It is possible to use an index starting from 0. Okay, so for example, if you want to access by index, you can do that. Look now, for index and x in enumerate my list, it will create an enumeration. So enumeration is composed by an index and a value. Okay, so the index will be the index of in the list, and the value will be the value that corresponds to that index.
enumerate, it's the location in the memory or what?
No, it is a function
Okay.
that will convert a list to something like a map. Okay, but the map here, it's like you have the index, okay, and you have the value that corresponds to that index. For example, imagine that you want to print only index 3. You can do if index equal 3. I need to do double colon here. Okay, so here if you want to make an if statement, you cannot. By index, I mean, using the index. It's like, now in Java, it's like when you want a for each statement, or you want to use a for loop using int I. So you can choose any of these. This one is the for each statement in Java. And this one is the classical for int I, so where you can have access to the index. I try to make analogy with Java because you have already taken a course in Java to understand. We can delete an element from the list. Okay, so I delete the index 2, and the list is going to change its size. So here we can add. For adding, there is no adding, but you can delete from the list. So you can see here, I cannot add this element. It is out of range. No, we can do that here. Just a moment. Yeah, there is dot append, yes. But I need to go back to the list itself. Delete an element. Look, you cannot just write index 3 without having the index 3 defined. It will say out of range. So the operation that you can do on the list, you can do several operations, getting the element, concatenation, repetition, membership, and iteration. So len, it will return the length of the list. Len, my list. So here we have only 3 elements stored from 0 to index 2. You can do list concatenation. So for example, let's define second list 2. You can define a list that concatenate first list plus the second list. So it will take the element of the first list and will append the element of the second list. Okay, so this is the way on how to add elements, is to create another list that you make concatenation from another one. You can make list repetition also. Multiplying by 3, what does it do? It will create the list 3 times. 1 Salah true, 1 Salah true, 1 Salah true. Okay? So you can see a lot of capabilities now that you can do with the lists. So here also you can do different operations. We start by a list that contains some numerical values. You can find the max, the mean, and the sum. Okay, the maximum value is 9, the minimum value is 1, and the sum of the values is 37. You can also use dot sort. Of course, if we assume that you have comparable things and they can be sorted out. Okay, look now, if I do, now,
كان عندك different types.
ولا أنا عملتها. If I have 1 and 5 as, so it will not, it cannot do even the maximum or sorting, you know. You cannot even do the maximum. So they must be the same type, and the type must be comparable as well. Okay, so you can sort, you can print the list sorted. Look now, the list is sorted. You can append elements, and here you can add elements to the end of the list. You can, for repeated 1 time. So imagine that I put 4 2 times. Yeah, okay, right. But the index
Shows where it's located. Where 4 is located. Position. It's for the position 2.
okay, exactly right. Right. Yes. So this returns number of instances. Okay, how many times 4 has appeared, and this returns its index. So we can insert at a certain index as well. مثلا نسوي add at certain element في الارray list. And you can define, here we define a list of string values, CS, IS, and SE. So we can also print the min and the max. It's going to make the alphabetical order. We can also sort. So this is another example for defining the maximum, the minimum values, and the sorting. You can also make reverse to make it in the reverse order. Okay, so look here, when we made reverse, it starts by SE, IS. So if I make reverse equal to false, it will start in the increasing order. And of course now, every method, for example, if I make sort, list, sort, Python. So every method usually it has a lot of parameters and arguments, but most of them are optional. You can activate them and you may not activate them. So for example here we have used sort without any parameter, so it is going to make the default order in the ascending order. But now looking at the sort parameters, that makes my book as add here. I want to show you the different options that we can find. Look, this is the method sort, and it has 3 optional parameters. 3 optional, it means you can call any of them or none of them, or all of them. So here in the second example we called reverse. It's a Boolean value. If set to true, the lists are sorted as if each comparison were reversed. Okay? For example, in the case of string comparison, it will be in the descending orders, from the biggest to the smallest. Okay, here you can add the custom comparison criteria. It's similar to what in Java? Comparator. It is similar to the comparator. Okay, here you can add the key, specifies the function of one of the arguments that is used to extract the comparison key from each list element. Clear? So for indexing and slicing, this is an important topic to understand also. So the index in Python starts from 0. This means that the list I element is located at the position I minus 1, since the counting starts from 0. The index may also be negative. So what does it mean minus I? It refers to the element and index starting from the right.
The last element?
Yes. So for example here, minus 2, 0, 1, 2. So it's going to return, it starts by minus 1, it seems. Yeah. So look here, minus 2, it returns 22. minus 5, 1, 2, 3, 4, 5. It returns Muhammad. So from the right side, it starts from 1. Okay, and from the left side, it starts from 0. Okay, so here you can specify elements. So at index 2, which one at index 2? 0, 1, 2, 3.2. It will be 3.2. And here minus 2 is going to return 22. It is also possible to slice the list as follows. Okay, so what does it mean, this one? All the elements from 0 to 3. Okay, this is a slice. So it will include all these 3 elements. Now here it's exclusive. Always the AND index is exclusive in almost any programming language, at least the ones I know. حتى في الجافا حتى في السي نفس الشيء. The AND index is exclusive. Okay, so here is going to return 0, 1, 2, 3 elements. From the right, so what does it mean? Return the elements from index 3 to the end. So it will start from index 3 till the end.
With the last element or exclude the last element?
With the last element, yeah, till the end. Okay, we did not even specify anything here. So it will take up to the end. And it will start by the index 3. Okay, so here, double colon and the value, you start from 0 until the last element minus 1. And here, you start from the index specified till the end. Now,
If you remove the 3, it will print the whole list or not?
which one?
Here, you put the column without the number.
The column without the number.
Yes, it will print the whole list or it will give out an error.
هكذا?
Yes.
So it will print everything. It will print everything from the beginning to the end. It's like you do like this. Okay. So you can create random values also. You can create some random lists, like we use math.random. Look at this here, we import random. This is the package that we use. And here you define a seed value, which is optional. What does it do with the seed? Do you know what does it do with the seed? It changed the randomness. Look now. If I execute this several times, رغم اللي مسوي sample, it means random values. Does these random values change? No. Imagine that I change the seed. They will change. This depends on, okay, because you have to understand how random numbers are generated in a computer. So random numbers generated, they usually start from a value, and then there is an algorithm that will generate some other values based on the first one. So usually if you don't change the first one, that is called the seed. Here seed يعني الأصل البذرة النبتة دائما it's going to be the same thing. Okay, so when you want to have different kind of combinations of random values, you need to change the seed. If you make the same seed, it will generate the same random numbers. Okay, this is how random numbers are generated by computers. Depends on their ways. So this was about the lists. Okay, so the next data structure in Python is the tuples. And tuples are similar to lists, but they are immutable. What does it mean immutable? You cannot be changed. الآن بالنسبة للlist we can append values, we can remove values, but for tuples, once they are established, they will be static. You cannot change them. So here we create a course. Okay, this is how we can create a tuple. Okay, instead of using these brackets, we use parentheses. هذا هو الفرق في notation. So here we use, for the list, we use brackets, and for the tuple we use parentheses. لو تسكروا المكيف هذا. Okay, so this is the difference for how to represent them. So this is a tuple, CS102, Java Programming, 25, 2018. Number tuple, you can create letter tuple, you can create an empty tuple, and then you can print it also. So if it is printed like this. So basically it's the same, but you cannot change it. Huh? Yes, you cannot change it. But it is possible to access an element in the same way by its index. Okay. It is also possible to make a for loop. نفس الطريقة. It's the same way. The only difference is that you cannot change. It is not possible to update the tuple. Look now, you want even to change the value, not even adding elements. You want to change the value from, for example, CS102 to Introduction to Python. And now, tuple object does not support item assignments. You cannot do that. You can only read them. It's like read only data structure. Okay. But you can create other tuples by combining two tuples. So number tuple plus letter tuple is going to create one other tuple, okay, that is extended like this. So if you want to delete, of course, you can delete it from the memory using delete. So delete it can be used to delete variables, tuples, lists, objects later on. Okay, just removing it from the memory. And what operations you can do? You can find the length of the tuple using len in the same way. You can also make multiplication. It's going to create the tuple twice. And you can check the membership if the course, if CS102 in course. So it will check one by one values. Okay, so you don't need to go element by element. You can just do in. Even for the list, you can do the same thing. If CS102 in course, in this case, it will print. Okay. Now, if I change this one, it will take the other. Okay. You use it whenever you need something that you will not have to change. Okay, so it depends on the usage. I mean, the same thing you can with a tuple, you can do them with a list. But if you want to enforce that this data structure is immutable, in this case, you have to choose tuple. Okay. It is possible to find the mean and the max also. No? It's almost the same operation that we did on the list. You can do them. For slicing, the same thing. So what does it mean this? Start from index 2 till the end. Okay, yes. Yes.
X will end equals comma. Take a شيء كان الكوما يطلع شيء جاي.
Here, it will change everything by plus. Everything. So this means like something you want to use as separator between the words. If you don't put and, it's possible, but it will print one by one like this. It's /n by default. But then you can put, this is another option. As I told you, the language is very rich. So you can put and equal and then specify what is the separator. Okay, if I put /n here, it will just do the default thing. Okay. So here we have slicing and matrices. Also, we can do slicing. We can use the selecting an index, and this is different from selecting an element and index 2. It is possible to start from the right side also in the same way. So basically, it's the same things. The only thing that you cannot do with the tuples, modifying the values. What does it mean? No, you cannot modify anything. No, you can't modify anything. Now the set. So what is the characteristic of the set? It's universal, by the way. Does not have duplicate values. Okay, like in Java or in any other programming language. So a set is a collection of elements. So for now we have learned two data structures. List, let's say like an array or an array list. The tuple is something more specific that you cannot change. And now we will have another data structure that is also a sequence of elements that does not allow duplicate values. Okay, which we call the set. It does not have any particular order. And if you remember in the sets in Java, we don't have the method get because there is no particular order. Of course, we can also use comparator to organize in some of the way, but doesn't have actually like the notion of an index. And when we define sets in data structure, you have already data structure course. This is actually the set that is defined in general data structure, and it is implemented in different ways or different programming languages. And elements in the set cannot be changed. This is specific to Python. Okay, they are immutable because in other programming language we can change the values of the set, but the set can be changed. The set itself is mutable, but not the values, the elements, not the elements inside. It means you can append elements, but you cannot change an existing element. And no index attached to any element. We already defined this. So here let's define the day list like this. So this is a list, and you can see in the day list we have Monday is repeated, and so we have Monday is repeated twice. So we can convert the days into a set by making a casting here. We cast the list to a set, and days 2 here. Yeah, so we define a set with the curly brackets as well. So these are different ways on how you can define the set. Either you cast an existing list to a set, okay, or you use curly brackets to define the set. Look now, here we don't have any, Monday is repeated only once. Okay, so this is the same set also defined in a different way. Although here we have Monday, Tuesday, they were removed. Look now, if I change this one to like this, to a normal bracket, so it becomes a list and it has duplicate values. But if I use curly brackets, and curly brackets in this case define the set, it will automatically remove the duplicate values. Okay, so same thing for months. Look, months, we have here January repeated twice, and at the end it ended up by removing the duplicate value. We have dates and so on. So this is a way to use only a collection that contains unique values. You use it for keys, for example, or for maintaining some unique features. Okay, these are some other examples, and every time is going to provide unique set of values. So you can also access the value of a set using a for loop. We cannot access a particular element, so there is no indexing. Imagine that you want to do, let me create another cell here. If you want to make, we have days of 2. Set object is not subscript. Okay, so we have an error here because you cannot access any index. Okay, we can print all the elements. It will be in any order. And we can add and remove element from the set. We have said that the set is mutable, but their elements are immutable. Okay, so the set is mutable, it means you can add months.add April, yeah, we can add it. Okay, I can add, for example, another month, December. So it's there. Imagine that I add April another time, no effect. Okay, so you can remove element. And of course, since we don't have any way to access the elements, they are immutable. You don't have access to them. You cannot say change this particular value or this other particular value. But what you can do, you can remove a value that you don't like and add another value that you would like, and then this kind of replacement. So the operation on the set, it is possible to perform different operations on the set. Where is this card? It does the same thing. Same thing. So here you can do union, intersection, difference, comparison. So this is, we convert a list to a set, or we create a set like this. So we can do a union. It's like you are adding. Okay, we cannot do add like this, at least as far as I know. It's not possible. So the union is like union of sets. And you can do intersection. You have two sets. The intersection here, they intersect on Ali. This is the only common value. You can make the difference of sets. What are the elements that are different? Name set difference. Kamal and Khalid only. The difference here is this value minus this value. So it will remove everything in common. Okay, if I make 1 minus 2, what does it return? Muhammad Salah Munir. Okay. It will return Muhammad Salah and Munir. You can also make a comparison between the sets. Name set 1 is greater than name set 2. False. So this is a comparison. Okay, here we cannot compare because they don't have the same number of the same elements. And here we compare 3 with 2. It's possible because 3 it has only Ali and Kamal, and here it has Kamal, Ali and Khalid. So the fourth data structure is called dictionary. And this dictionary is a collection of key value pairs. And this is what we call in Java as maps. Okay, tree map, hash map. Okay, it has a key and a value. It's like a two-dimensional array where you have the first column is for keys, and then the second column is for their corresponding values. So each key is separated from its value by a column, and the items are separated by commas. So this is the key, and this is the value. And it's not exactly like in Java, because in Java you define a type for the keys and the type for the values, but here you can have any, it's dynamic. So here I will use a key as a string and the value as a string. Here a key as a string and the value is float. Okay, so this is possible. Yeah, no, it's not a problem. I mean, I'm not sure whether the key it can be something like this. Yeah, it's possible. It can be any type. So the most important is that you have something that have some sense, make some sense. Okay? So an empty dictionary without any item is written with just two curly brackets. You can define an empty dictionary and then you can add elements as long as you move. The keys must be unique. You cannot have, this is known, you cannot make name, for example, two names. Okay, if you do something like this, it will just take the last one. Okay, because the key is actually unique. And the value may not be unique. The values of a dictionary can be of any type, but the keys must be of an immutable data type, such as string, numbers, and tuples. هذا بالنسبة للconstraint on the key. الكي يمكن يكون string, numbers, or tuples, something that you cannot change. So how to access a value in dictionary? Of course, we can specify the key in order to access the value. Okay, for example, if I define student1 like a dictionary here, okay, student1, and I can put the name between brackets to specify that I want the value that corresponds to this particular key. Okay, and the GPA here will be student2 dot or not dot between brackets GPA at index GPA. So it returns 355 for the second student. And you can see here the dictionary has 4 elements, and this dictionary has 3 elements, so you can define a number of elements in your dictionary. It is not permitted to access a key that does not exist. For example, here we don't have the age for the student one. If you do like this, it will be an error. So how to update the dictionary? You can change the values. Okay, for example, I want to change the GPA of student 1 by just making an assignment, and then the GPA is going to change, as you have seen. We can also add a new key value pair. Look, the age was not defined in student 1. I can add it. You just need to define a new index and then assign the value, and then list of courses, and then I put a list here. Look now, the new dictionary, look, courses is taking a list. So I have a list inside the dictionary. You can put any other data structure as well. So it's very flexible. Okay, because Python is dynamically typed, so you can put anything in the values. You can put objects, you can put string values, you can put data structures, anything can work. So if you want to delete an element, it is possible to delete the whole dictionary or to delete a particular key value pair. Okay, so here, for example, I can delete student 1 age, remove the entry with the age. let me print student 1. Okay, I did not execute the code because okay. Clear removes everything. Clear. Look, if I remove student 1 age, okay, here you have the age, and here I don't have the age. You can delete all the dictionary, student 1 dot clear, remove all the entries. It will become empty dictionary. Okay, and you can delete the whole dictionary from the memory, not even empty. It does not exist anymore. So you have to differentiate between clear and delete. Clear, the dictionary is still in the memory, but it's empty. There are no values or key value pairs. And delete, there is nothing called the dictionary anymore. Okay, so let me make clear here. Okay, you see? Now if I put instead of clear, delete, is not defined. Okay, now I have to define it again. Delete a dictionary element. Let me create the dictionary again. So you can loop over a dictionary using the for loop. So this is for each statement. It means for every key value in student 1. And then if you want to access to the value, you can make student 1 between parentheses, between brackets key. Okay, so for every key in student 1, okay, you can print the key and you can print the corresponding value. You can also print all the items. For example, sometimes you want to see all the items at once. Dot items will do the job. Okay, it will print you dictionary items, name, value. So it will group them into key value pairs. Another way also, and this is common in also many programming languages like PHP and JavaScript. So you can use for every key and value in student.items. And then you can write the key and its corresponding value. You can do that, or you can do that. So you cannot do in student. It's not going to work. If you want to use key and value, you need to call items. Okay, in this case, it will work. And student.values1, it will return only the value. So you can return only the keys, or you can return only the values. Like in Java, when you do with the map.keys or map.values, it will return you either the keys or values. Okay, now we move to the topic of lambda expression. Do you know about lambda expression? Have you heard about this? No. It's a new way to for expression. It's like making a shortcut. Yeah, function without name, and it makes a shortcut. With Java, I started with Java 8. So Java 8 started with lambda expressions. I don't like too much, maybe because I didn't use it that too much. But anyway, I'm going to present the way to make shortcuts. It's being used in Java, in Python, in many programming languages, either in C from version 11 and above. They define lambda expressions. They are useful because sometimes when you get used to them, they can actually simplify the writing of your code. Instead of writing in a function, then calling the function, you can make an inline function that will do the job. So lambdas are one-line functions. They are also known as anonymous functions because without a name. In some other languages, you might want to use lambda expressions when you don't want to use a function twice in a program. So you want to make a function only one time. They are just like normal functions and even behave like them. So this is a lambda expression. So div, and we write lambda, and then your input, the function arguments, and the function output. Yeah, this is a lambda expression. So this is it's like you do a function that will take two arguments, two parameters, and then it will return x divided by y. This is a lambda expression.
Is it limited to one operation?
No, it's you will see several ways, but it's mostly used in operations. So to have an inline function. Because now, if you don't use this one, what you will do? You will make def div f function. You make xy return x divided by y. So this lambda expression replaces all of this. Instead of making then div f xy, you just do that. Okay, so we can do now. We do the same thing. Okay, so this is the function div. Okay, that we define. Okay, another lambda expression here. You have a list, and look at the list here. It contains tuples. It's a list of tuples. Okay, and we can define the first element function. It's a lambda expression. For every x you give, you return the first element. And then we apply this. MyList.sort. So this is a function that we execute. It will return the first element. So key, if you remember when we talked about the method sort, it has a method key. It has an optional parameter that is called key, and specifies a function of one argument that is used to extract a comparison key from each list element. What is the first element here? If we print, okay, let's remove this one. If we print first element, my list.
This prints the second element.
Yeah.
Next to
X1, yeah, so the second element, yes. It's the second element. Yes. And here it's using the sort. So why use lambda expression? The power of lambda is better shown when you use them as anonymous function inside another function. Okay, for example, here define power exponential of n. Lambda a equal a power n. Look here. You define a function from another function. It's more complicated, this one. Look, this one. What do we return here? We return a function. So power exponential is going to return a function that will make the power of the function at L. Yeah. So here we define a function square exponential that will make exponential of 2. And here cube exponential is the power exponential at 3. So when you make square exponential of 5, okay, it will call this method. It will make, okay, it will make 5 power 2. And here if you call cube exponential, it's a function defined from the function power exponential. It's a new concept. You didn't see this in other programming languages. So here this function is going to return another function, not a value.
Like an object.
Yes. And this other function can be used to be called by, yeah. So we end up the session of today by the 6th data structure: map, filter, and reduce. These are 3 functions which facilitate a functional approach to programming. So map applies a function to all the items in an input list. So the usage here is you use a map, the function to apply, and list of inputs. So here we define a list of days, and then we have a lowercase days. We want now to convert this list into a list with all values as lowercase. So we want to apply the lowercase to all the elements. So what we will do, we can do, using a for loop, we can make I.lower, okay, for every element here, using a for loop. So here we didn't use a map. We didn't use a map. Just we use a for loop, and then for every element we just use call the method.lower to change the value, and then we can get the output as here. الآن the exercise is the following. You have a list, it contains string values, you want to lowercase all the values. The first way is to use a for loop. For every element, just apply .to lower, and it's going to make to convert the string into lower. We didn't make any this one .append, so we make a new list, and then we append the new values. The list was empty, and then you append first value, second value, third value, and value.
The original list did not change.
Did not change, yes. If you print this list, it's going to be the same. Now, the other way is to use a map. So the lowercase day is a list, right? Okay? And in the list we will apply the map function. Okay? And we will use a lambda expression. For every value, apply s.lower. So this is the function that we will use. And we apply to the list days. I know it's a bit complicated because it's something new, but it's possible in Python to apply a function to all a structure, to all the elements of the structure. Okay, so every element in days is going to be applied to this function. Okay. مثلا if is it possible to compare? Okay. You can make to upper, and it will change all the values. Look here, another list, and you create a new list that will apply this function to all the elements. If the values, so what does it mean? If the values is greater than 3, it will return true, otherwise it will return false. So this is a way where you can convert all these elements into true or false based on the conditions that you have. واضح? Of course it has different usages, but this is a way. So map here, you provide a function that will be applied to all the elements of a list. So filter, it will actually make a filter that creates a list of elements for which the function returns true. So you have several elements, you will only put the elements that will satisfy the condition. Okay, so here we have days, and then we can create a filter using the lambda expression, start with S. So it will only keep the days that start with S. And here you have Sunday and Saturday. So if you put a map here, it will make true or false. شفتوا الفرق؟ Okay. However, filter here, it will just keep the values that corresponds to the condition. Okay. Same thing here. If I do filter, it will keep the values for the condition. Reduce. Reduce is a really useful function for performing some computation on a list and returning the result. It applies a rolling computation to sequential pairs of values in a list. So, for example, if you wanted to compute the sum of a list of integer, the normal way is to make a for loop and then compute the sum of the elements, صح ولا لا? Like here. For every exam grade, total equal total plus grade, and then you return the total. But what you can do, you can use reduce, which you have to import from functional tools. Total equal reduce, you define the lambda expression, okay, x, y, you make x plus y. And here apply to all exam values. Okay. So with this we reach to the end of the Python introduction course. I have another notebook about object-oriented programming. Inshallah, we will do it in a later stage. But you can go through it. It's very short and simple. Inshallah, when we have time, maybe one of the Thursdays and so on, we can continue this part. But now at least you have the most essential things to start with. Then you can look into other references, and you have tutorial points also. But now with this, you can practice. I put you also here some exercises to practice, Python exercises. I think I put the solutions, so if you want, you can just try to remove the solutions and then try to do it on your own, just to practice a little bit about the syntax. It's quite easy, and with the time you're going to learn more and more functionalities of Python. Okay.